Hello and welcome to another Algebra 1 lesson by eMath instruction. My name is Kirk Weiler and today we'll be doing Unit 11, Lesson 7 on linear regression on the calculator. In our last lesson, we looked at how to draw a scatter plot and how to draw a line of best fit on that scatter plot. We also looked at how the variation in one variable can be correlated or even cause the variation in another variable. Today what we're going to be doing is doing those scatter plots and lines of best fit on our graphing calculators. So make sure to have your graphing calculator handy. Here we go. All right, so the best fit line. This is also known as linear regression, which is kind of a fancy name, but you sort of have to know it. Now, calculators can find the equation of the line that best fits any data set. The method the calculator uses is fairly complex and will be explored more in college-level statistics courses. So let's jump right into it and see how our calculator can produce both a scatter plot for us and the equation of the line of best fit. A sample was taken of 10 low and high temperatures for a given day in Fahrenheit in the month of April to try to establish a relationship between a day's low temperature and its high temperature. Awesome. Now, if this data set looks familiar, it should, because it's actually the same data set that we began with in our last lesson. So we created a scatter plot by hand for this data in our last lesson. We drew in a line of best fit as best we could, and we even calculated the slope of that line of best fit, all of which we're going to kind of take a look at in a little bit. But let's take a look at letter A and get our calculators involved. Enter data into lists on your calculator. Create a scatter plot using your graphing technology. Size the window appropriately so that the data takes up the majority of the screen. Compare this to the scatter plot you created in the last lesson. Awesome. Okay, now how we enter data on a graphing calculator is very dependent on what graphing calculator you use. As usual, what I'm going to be using is the TI Inspire. So let me just open up my TI Inspire right now. And just like the work we did earlier on a single variable in statistics, what we're going to do is we're going to add a list and spreadsheet. That's going to be choice 4. Now, what we want to do almost always is put the data in terms of our X value in column A and put data in terms of our Y value in column B. I even like to go up and give column A a name and column B a name. In this case, I would call column A low temp or just low. I would call column B high temp or just high, whatever. What I'd like you to do now is pause the video and on your calculator, put those X values, those low temperatures in column A or list 1 or whatever your calculator calls them, and the high temperatures in list B. Pause the video now and take a few moments to do that. All right. Well, for me, I've already got this data in the calculator in a separate file, so I'm going to go ahead and open up that file now to save us a little bit of time. Open up my document. That's this guy. Nope. And there we have it, right? We've got our low temperatures, we've got our high temperatures. We're ready, right? We just want to create a scatter plot. Now, in order to do that, what I'm going to go back to is my home screen, okay? And on my home screen down here, I can choose another thing to put into my document. So I'm going to put in a graph, okay? I'm going to go up to menu, as I always do. I'm going to go into graph entry edit. But now, instead of putting a function in, what I'm going to do is I'm going to put a scatter plot in right here. Now what I have to do is I have to tell it my X variable and my Y variable, and I'm going to get those using my variable key right here, and hopefully it works. Sometimes it gives us a little bit of a problem on this. I'm going to put low in, and then I'm going to put high in. I'm going to hit enter, and I don't see anything, right? And I don't see anything because my window isn't sized appropriately, right? But it's really easy to size my window appropriately because I've got my data, right? My lowest low is 26. My highest low, which is a little bit weird to say, is 45. So maybe I could go from 20 to 50 on the x-axis. And then in my high temperatures, right, my lowest high is 50 and my highest high is 72. So I could go maybe, I don't know, 40 to 80, right? So let's try that, 30 to 50 and 40 to 80. All right, let me do it. So let's go menu, window settings. All right, what do I have? I had I want 20 to 50. And then what did I say? Let's see, maybe 40 to 80. All right, and there we have it. Look at that, right? A scatter plot that is just beautiful, okay? It's a little bit weird because you can't see the x-axis or the y-axis, but if you compared this to the scatter plot that we made in our last lesson, it looks almost identical to it, except of course we don't see all of the grid and we don't see the axes. We don't see the axes breaks or anything like that. Honestly, in order to see the axes, we'd actually have to bring it all the way back to the 0, right? We couldn't actually have the axes breaks in it. So we've got that. Let me put this away for just a moment and let's go back up to view, full screen, and let's take a look at letter B. Use your calculator to find the equation for the line of best fit. Round the slope of the line to the nearest hundredth and the y-intercept to the nearest integer. Compare this to the slope that you found in the last lesson. All right, so let's talk about how to find the equation of the line of best fit using our graphing calculator. All right, I'm going to go back to my data set, okay? And now I'm going to go into my menu, and I want to go into statistics. I want to go into statistical calculations, and choice 3 is linear regression. Linear regression mx plus b, right? Y equals mx plus b. Now what's really cool in here is I can now in my x list click on that and I can click on the word low. In my y list I can click on the word high, and that's because I have labeled those in my lists, right? If I didn't, it would be a little bit more confusing. Now notice it also says save regression equation 2, and in this case it says F2. Normally it would say F1 there, but I already have something in F1, so it's gonna like save my regression equation in F2, which is wonderful because eventually I kind of want to graph it along with my data, right, to see how well it really fits. Anyway, I can kind of go all the way down here. There's not much else here. I'm gonna hit OK. And everything just magically shows up here. One of the other great things about the TI Inspire is that if I start changing this data at all, it will start changing these values over here. But right away, let's take a look at this, right? What I see is title, whatever. That here it says regression equation m times x plus b. Then it gives you the value of m, 1.10755. And it gives you the value of b, which is 21.178, etc. Now in this particular problem, it asked me to round the value of my slope to the nearest hundredth, so that would be 1.11, and it asked me to round my y-intercept to the nearest integer, that would just be 21. So at the end of the day, I can finally, after all is said and done, I can finally write my equation for my line of best fit. Let me first just get all of this set. And now let's go into full screen, and we have y equals 1.11x plus 21. Now, we don't have our view from the last lesson. And remember, in the last lesson, we drew a line of best fit, but yours may have been different from mine. My line of best fit from lesson 6 had a slope of 1.2. Right, versus 1.11. Not too bad, right? Pretty close, only 0.09 units away. Now, this really is truly the best fit line, not the one that we drew. That one we sort of eyeballed, if you will. Now let's talk a little bit about interpreting both the slope and the y-intercept of our line of best fit. Let's take a look at letter C. Explain what the y-intercept of this model represents in terms of the low and high temperatures that are being modeled in this problem. All right, so what does the y-intercept represent? Pause the video now and think about this, and this has nothing to do with linear regression. This is just all about what the y-intercept generally represents in a linear model. Pause the video now. Well, remember, the y-intercept is always the y value when the x value is 0. Now, remember, the x's here were the low temperatures, and the y's were the high temperatures. So literally, what this number is telling us is that when the low temperature is 0 degree Fahrenheit, our model predicts the high temperature will be 21 degrees Fahrenheit. And that's it. When the low temp equals 0 degrees Fahrenheit, the high temp should be 21 degrees Fahrenheit. Or at least that's what the model is predicting it to be. All right, let's take a look at letter D. A day in April has an unusually warm low temperature of 52 degrees Fahrenheit. What does the best fit linear model predict as the high temperature? Well, okay, go ahead. I mean, you've got a model now that is predicting the high temperature if you know the low temperature. Use that model to predict the high temperature when the low temperature is 52 degrees Fahrenheit. All right, let's do it. So it's simple enough. In this case, they're literally telling me that X is 52 degrees Fahrenheit. So we can now just plug that into our equation, 1.11 times 52 plus 21. We'll need our calculator here in a moment, but let's just kind of get that all written out. Simple enough. I'm just going to kind of bob over to here. 1.11 times 52 plus 21. Enter. And we get 78.72. Awesome. Easy enough. Let's go back in. So our model predicts 78.72 degrees Fahrenheit if we've got a low temperature of 52 degrees Fahrenheit. Now let's take a look at letter E. Why might it not be wise to trust the prediction made in D? All right, so think about this a little bit and really consider it given the data set that the model was created on. Why would it be maybe not a wise idea to use the prediction that the model gave us? Well, it's really about that unusual low temperature, right? That low temperature of 52 degrees Fahrenheit is not within the range of the low temperatures that was used to develop the model. So we don't have a lot of confidence in best fit models when they do what's called extrapolating. And that's going outside of the range of the data to make a prediction. All right, so I'm just going to say the 52 degrees Fahrenheit does not lie in the range of the low temperatures. Maybe I'll just use temps used to create the model. So in other words, I'd feel pretty good about using my model to predict a high temperature if I was given a low temperature that was somewhere in that range of the low temperatures that we use to develop the model. But as soon as we go outside of that, I might not feel as comfortable. In fact, I might not feel as comfortable in the other direction as well. In other words, if you gave me a low temperature, let's say of 0 degrees Fahrenheit, I'm not sure I would want to use this model either to predict the high temperature, because the 0 degrees would also not be in the range of those low temperatures. That's called extrapolation, when we use a model to predict things that are outside of the data set that was used to develop the model. It's interpolation when we use it to predict things that are inside of the data set. Anyway, let's keep going. Let's do a little bit more work. All right, let's take a look at another linear regression problem on the calculator. Exercise number 2. Generally, the fuel efficiency of a car changes with the weight of the car. A survey of 8 cars with their weights and gas mileages is shown below. All right, so let's get a feeling for this for a second, right? In the first column, we've got the weight of the car, and this is important, in thousands of pounds. So there's not very many cars that weigh 3.7 pounds or 4.5 pounds, 3.2 pounds, etc., right? This is actually 3,700, this is 4,500, 3,200, etc. And then the mileage, in other words, how many miles that car will get in per gallon of gasoline that it uses up. So in other words, we found that a car that weighed 3.7 thousand pounds would get 38 miles to a gallon, 26 miles a gallon, etc. Okay, so letter A. Find the equation for the line of best fit using your calculator. Round both coefficients to the nearest tenth. List what the variables x and y represent in this problem. Okay, so this is again all about just putting this data into your two lists, putting the weight in x, putting the mileage in y, using the line of best fit, like option on your calculator to come up with that equation. Go ahead and do that. All right, let's do it. So, yet again, for me, the great thing is I have this already stored in my calculator. So I'm going to just go over to File, I'm going to open Document, I'm going to go down to this one, I'm not going to save the changes to the last one, and here we are, right? We've got weight in category A, we've got mileage in category or column B. It's time to create or to get that line of best fit. So I'm going to go right away to my menu. All right, I'm going to go to Statistics. Not going to be able to say it very well, but I'm going to go to it. Now I'm going to go to Linear Regression, choice 3. All right, in my X list, I want my weight. In my Y list, I want my mileage. It's going to save the regression equation to F1, which is really great, okay? So I don't need to like remember it or anything like that. It's just going to throw it right into that. And now I'm going to hit OK. And here we have it, right? We've got regression equation mx plus b, where m is negative 8.0973 and b is 68 point, et cetera, right? It said to round, I believe, to the nearest tenth, right? List what the variables, so it's round both coefficients to the nearest tenth. So for my slope, it's going to be negative 8.1, and for my y-intercept, it's going to be 68.1. So let's get that equation down. Negative 8.1 and 68.1. All right, let me go back full screen. Right, there's my regression equation, but it also says list what the variables represent. That's really kind of important to like remember, right? X is the weight in thousands of pounds, and Y is the mileage in miles per gallon. Awesome. The weight is X, the mileage is Y. Excellent. Let's take a look at letter B now. Create a graph of the scatter plot for this data. Give a sketch of it to the right along with the line of best fit. Label your graphing window. Okay, awesome. Let's do this. So let me exit here again, open up my TI Inspire. Now, in order to put a graph in, what I'm going to go is I'm going to go back to the main menu and I'm going to click on my graphing icon. Now, what's really cool is notice already it says F2 here. If I go up to F1, that's my regression equation in all of its ugly glory. I mean, it's got like all of that ugliness in there, and it's okay that it's got the extra decimals. I'm not too worried about that right now. But let's go into menu. Let's go into graph entry edit. Let's go into scatterplot. Okay. What I want now is I want my weight in X. I want my mileage in Y. We already talked about how to do that with the var button. So I'm going to do weight in X, and I'm going to do mileage in Y, okay? And again, I don't see anything because all of my data isn't in this window, unfortunately. Okay, it's just not there yet. That's okay, right? Let's take a look at what a good window would be. Now, all of my weights are between, 3.2 and 6.8 thousand, all right? But I think that we could actually start at 0 there and maybe go up to 8, I don't know. And then my mileages, the highest one there is 48 miles to the gallon, so we could certainly get it in at 50. So I think we'll go 0 to maybe 10 and 0 to 50. Let's take a look. 0 to 10, 0 to 50, go into menu. window settings, 0 to 10, 0 to 50, enter. Let me just move this. Now, we've got our scatter plot there. It's pretty good looking, maybe a little bit ugly, but it's there, right? And now what we also want is we want our line of best fit. Now, if I go into menu, it seemed weird, right? Because my line was there. And if I go into function, the problem is it's not checked off. And there we go. So now I'm gonna go back into here, move this a little bit, and take a look, right? Beautiful, right? We've got our line of best fit, we've got our data, everything is there. My equation might be a little bit getting in the way, so I can't see it very well. And there goes my falling arrow. All right, so now we just want to do a little sketch of this. It doesn't have to be the best sketch on earth. We just kind of want to get a sense for what's going on here. So let me just put this now on handheld only. We'll go always in front so that we can do a little sketch. Let me move this thing up. Again, I'm not looking for this thing to be perfect in any way. That was 0 to 50, that was 0 to 10. We had kind of a point. Almost looks like a constellation here. Maybe a couple of them right here and here. And maybe I'll even change this to red just so that we kind of have the line of best fit in a different color. Go back to blue. And there it is. All right, let me just bring this back up to this and minimize it. And we've got our line of best fit. So the calculator can literally do everything for us. And quite frankly, right, nobody in the real world draws scatter plots and lines of best fit by hand, okay? You may be required to do that on a standardized exam, but in the real world, you use statistical programs like Excel and other programs, maybe even graphing calculators, to create those graphs for you, and certainly to come up with these equations for you. All right, now let's do a little bit of interpretation. Letter C. Would you consider the correlation between weight and mileage to be positive or negative? Which parameter of the linear model directly tells you this? Okay, so is this a positive or negative correlation? And what part of this model actually just literally says, oh, this is it? Pause the video now and think about this for a moment. All right, well, this is a negative correlation, and it's negative because as weight goes up, right, the mileage goes down. It's that simple, right? As the x variable goes up, the y variable goes down. As weight goes up, mileage goes down. So this is a negative correlation. Now, the other piece though is what part of the linear model basically just directly tells you that? Well, it's the slope, right? Quite frankly, the fact that it's a negative slope, even if I didn't see the picture or know anything else, I would know it was a negative correlation because that's what a negative slope tells you. It tells you when the change in x is positive, the change in y is negative. And if the slope had been positive, it would mean that if a change in x is positive, the change in y is positive. So you can always tell whether a correlation is a positive correlation or a negative correlation based on the sign of the slope. The y-intercept, totally irrelevant in terms of negative and positive correlations. So, the sign of the slope tells us this. I put a little exclamation mark there because it really is quite important. Now let's take a look at letter D. How can you interpret the slope of this model in the context of this problem? Use units in your explanation. So this is something that you're often asked to do, which is what does this slope tell you, right, in the context of this problem? Pause the video now and see if you can write something down. Well, remember, slope, right, is always, right, slope is always the change in y divided by the change in x. Now, in this case, that is the change in the mileage divided by the change in the weight, which is negative 8.1 divided by 1, right? So this really gives us a sense, right? When the weight changes by 1 something, we'll get back to that, then the mileage goes down by negative 8.1 something. Now remember, the weight was in thousands of pounds and the mileage was in miles per gallon, right? So what this tells us is that for every 1,000 pounds the weight increases, the mileage drops or decreases by 8.1 miles per gallon. That's it, right? For every 1,000 pounds that the weight increases, the mileage drops by negative 8.1 miles per gallon. So if you're somebody who really wants to get very, very good mileage, miles per gallon on your car, you want to then buy a very lightweight car. If that's not a big concern of yours, if you want some very heavy truck, that can go through the snow or to haul something really big and whatnot, then you don't mind having one that's a bit heavier. All right, let's take a look at letter E. If a car had a weight of 4,300 pounds, what would this model predict as its fuel efficiency, i.e. its mileage? Round to the nearest integer, use appropriate units, and make sense of your answer. Okay, so pause the video now and go ahead and figure out what the mileage or the fuel efficiency is on a car predicted by our model, given that the weight is 4,300 pounds. All right, well, let's go grab that model, right? That model was y equals negative 8.1 times x plus 68.1. So let's write that down. Here's the real key, right? What do we put in for x? And you can't put in 4,300. You definitely can't put in 43,000, but you can't even put in 4,300. In fact, if you do, you will get a massively negative answer for y, which doesn't make any sense. You can't have negative miles per gallon, right? The correct answer, not the correct answer, but the correct input is x equals 4.3, right? Remember, x is not the weight in pounds, it's the weight in 1,000 pounds. So when the weight is 4,300, the value of x is 4.3. So now let's figure out what the model tells us. All right, y equals negative 8.1 times 4.3 plus 68.1. All right, let's open it up. Let's go back to here. Negative 8.1 times 4.3 plus 68.1. Make sure I've got all of that right. 68.1, negative 8.1, all looks good. And we get 33.27. Let me just write that down real quick. 33.27, but then it says round to the nearest integer. So that's going to be 33 miles per gallon. All right. And by the way, by making sense of the answer, what I was really encouraging you is if you put in 4,300, right, then you should have looked at your answer and said, that makes no sense at all. But 33 makes a lot of sense because, right, if I look for one that's around that, right, 4.3, here's 4.5, it had 26, right? That's a little bit lower, right? And again, these things aren't fit obviously perfectly by that linear model. All right, let's go down to the last question. Letter F. Is there causation in this correlation? Explain. All right, well, we talked about the difference between correlation and causation in the last lesson. All right, what do you think? Pause the video now. And the answer is absolutely yes, okay? So causation is when literally the change in one variable causes the change in the other variable. So, does the weight of the vehicle or the change in the weight of a vehicle change the mileage? And the answer is yes. And you don't have to be a physicist or a mechanical engineer to understand this, right? A heavier vehicle will require more energy. How about energy? More energy to move. So it will use more gasoline. So absolutely, right? The weight, there is no lurking variable here. The weight of the car is directly causing the mileage to be different. All right, so there's definitely a causation here. All right, let's wrap this up. So in today's lesson, what we did is we reviewed scatter plots and lines of best fit, but we let our calculator create the scatter plot, and more importantly, we allowed our calculator to come up with the equation of the line of best fit. Now, how that is done is very, very calculator specific, but you want to know how to do it because I guarantee that is the kind of thing that will come up on a standardized exam. You are surely going to see a situation where you have a data table with two variables and you're asked for the linear regression equation or the equation of the line of best fit or what have you. And you need to know how to get those data lists in your calculator and then which buttons to push to get the best fit line. We'll be seeing that a little bit more in the next lesson, but not a ton more in this course because we're almost done. I'd like to thank you for joining me yet again for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.